I'm Mary Frank Fox, co-director of the Georgia Tech Center for the Study of Women's Science and Technology, the WIST Center. WIST co-directors, Carol Colatrella and Mary Lynn Ralph, welcome you to the 2015 WIST Distinguished Lecture. We are honored to have you, Maria Klawe, President of Harvey College, with us today as the WIST Distinguished Lecturer. And toward our lecture today, our thanks go to Dr. Archie Irvin, Vice President for Institute Diversity, for his leadership and for his support of the WIST Center at Georgia Tech. Thank you. We thank President Peterson and Provost Bross for their valued support of WIST. Our appreciation goes to you, Dean Zvi Galil, and your team at the College of Computing for co-sponsorship of this year's distinguished lecture. And I want to thank a fine team of graduate research assistants, especially this year, Abba Shah, Abba, and Catherine Klein, who enabled today's event. So, getting us underway now is Archie Irvin, Vice President for Institute Diversity.
So you sure you want that incomplete? Okay. Good afternoon, everybody. I know it's cold, but I can't. Good afternoon again. Good afternoon. Thank you, thank you. I have a really great job. I get a chance to work with some of the most outstanding academics in the country. And in particular, it's a privilege for me to work with the directors of the Center for the Study of Women's Science and Technology is a fabulous one because I learn all the time in every interaction that I have with them. I come away very humbled for knowing or realizing how little I really do know. But I'm a student of life, and I appreciate the opportunities to work with the co-directors that have been previously introduced. I'm not here to give a speech, so I'm going to say on behalf of the leadership of Georgia Tech, Dr. G.P. Bud Peterson, and all in Carnegie across the way, we're very pleased to be supporters of this event because we think it's important to keep these kinds of conversations vibrant and going. The future really depends on this. So I'm looking forward to the words that we will hear this afternoon. I had the privilege of picking our speaker's brain a little bit earlier today, and I came away much richer for the experience, and I know that you will too as this lecture is presented today. So again, on behalf of the Institute and the Center for the Study of Women's Science and Technology, thank you all for coming today, and I know you will enjoy the words of remark, and thank you for
Dr. Zvi Galil of the College of Computing introduces our WIST Distinguished Lecturer.
So it's a real pleasure to introduce Maria Klawe. I was asked to volunteer to do it because I know Maria for 32 years.
35.
Like a little over 32 years.
He only counts in powers of 2.
And also the lecture is part of the college celebration of 25 years for the college and 50 years for computer science and tech. So it's double celebrations. And those of you who don't know, Maria Klawe is a computer scientist and a great computer scientist at this because, for example, my student and I wrote a paper we were very proud of, and Maria improved it in a very elegant way. The matrices, you remember? he has much better memory than me because I already forgot everything. So as part of the celebration, and what I'll do, I'll tell you just a little bit about Maria, but I'll tell you two stories that start with me but end with Maria. So bear with me. So first about Maria. Maria is a leader. She was a leader at IBM. She was a leader in British Columbia. She was a leader in Princeton for the last 8 or 9 years. She's a leader in Harvey. She's a role model. She's a fantastic president, and I'll give you just one anecdote. Unbelievably, she knows all the names of the students. It's not a large university, but all the names of the students. And I am at awe because I can handle at most 5 names. You know, and it's not age. Even when I was very young, the maximum was 10. Okay, so the first story is the following. So the college was born in 1990. So what else happened in 1990? A month ago, I was in Israel for a conference, and I met Kunsu Park, Maria knows him, who is now the chairman of Seoul National University, computer science in Seoul National University. He's my former PhD student. And he just hosted in December the 25th version of a conference on algorithms. And because it was the 25th, the first one was in Japan. So let's go back 25 years. Okay? And there was this conference, and you see 1990. There was a conference in Japan, and as a result of it, it was the 25th, a Japanese guy came to Korea and presented some pictures from the first one.
I knew this was coming.
Some of which I will share with you. Okay? So I was there. Okay, so you see, I was invited to talk, and the second invited talk was Nick Pippinger. Question 1, who is Nick Pippinger? Yes?
Her husband.
Right.
Thank you, Miranda.
2 points. Okay, Mike, you keep tally, because there will be more questions. Okay, by the way, you noticed my paper is on only 1 page because I usually give talks under the condition that I won't write a paper. So, but who else was there? No, so this is Nick. This is Nick 25 years ago.
Yeah, I guess so. It's not a very good photo.
By the way, I knew Nick 5 years before Maria. Nick was a friend, and Nick was also a terrific computer scientist, was my inspiration to my best paper. And in fact, in 1979, about the same year he met Maria, I didn't want to go from Tel Aviv to Puerto Rico to present my best paper, and I asked Nick, he presented it, and he probably did a much better job.
Probably.
She knows I'm serious. Now, there was somebody else in the conference. Who was there? Maria. Now, since Nick and Maria met, they have been inseparable. Inseparable or inseparable?
Inseparable.
Inseparable. They're always together. Today, he didn't join us today, right? No.
He's on.
Okay. Now, here's a paper by Maria with Tom Lighton. Question number 2, who is Tom Lighton? Tom Lighton is a very prominent computer scientist, but also a millionaire because he's the founder of Akamai, $13 billion company.
He might be a billionaire.
Maybe. I didn't count. And question number 3, who was the co-founder? Co-founder was Danny Levine, the first person to get killed in 9/11, but I won't go there. Oops, I jumped to the end. So this is the picture I want to share with you from that conference. So question number 4, what do we do? Aha, karaoke, 2 points.
And what was the song?
I don't remember. Actually, so that's the first story. And frankly, I totally forgot 90% of the conference I've been at. But this one I didn't forget, not because Maria or Nick. Because I came back from Tokyo to JFK Friday evening. Saturday, 10 a.m. in the morning, I ran half a marathon. It's the only run that I did that I invited my wife and son. And it's only the run that I never finished. Because I was totally depleted. You know what it is to, it's a bit 5 miles, for 5 more hours now than to fly from Tokyo to JFK than it is for now. Simply was with no energy and I didn't finish. So that brings me to the second connection to Maria, is running. So both of us are ex-marathoners. And in fact, a few months earlier, and not a few months earlier, 2 months
later,
2 months later, Maria came to me and we ran together the New York City Marathon. And it was very hot, over 70 degrees, and she beat me. But I have an excuse. So I ran about 20 some marathons, and Maria ran a few marathons. Both of us are you still running? No. I'm still running, but not marathons. So this is the second one. So that's why I wanted to tell you about Maria, and we go back to a lecture, and I really forgot what she's lecturing about, so let's check. Getting more women into technology careers and why it matters. And as president of Harvey, she's also doing fabulous job in getting women into computer science. Ladies and gentlemen, Maria Klawe. And now I'll close it and open yours.
So let's test my mics. First of all, can you guys hear me? And secondly, you guys are okay with the video recording. Wonderful. So first of all, it's a great pleasure to be at Georgia Tech. And it's always a pleasure to see Zvi, whom I've only known since 1979. And he might have been one of the people who really persuaded me that being a university administrator was not such a bad thing, because he was having so much fun when he was Dean of Engineering at Columbia. And we even were Deans of Engineering together for a very short period of time. But it's also, frankly, a delight to be here and be talking about getting more women into tech careers, and to be here as a guest of WIST. And I want to thank Mary Frank Fox she has been the most incredible host I have had in my experience, that she has literally either driven me or walked me from every appointment I've had so far, and it's been absolutely wonderful. Okay, so are you ready to have fun? Yes. We're definitely going to have fun. But we're going to be talking about something that matters. So I guess I could take your clicker. Oh, you've put it away. OK, never mind.
No, I am not sure.
Says, I don't think you got back the part that. Oh, never mind. Never mind.
Okay, it's working.
Oh, it's working. Okay, so this one.
Yeah.
Yeah, I just want to have the fun of walking around. Okay, so here's what I'm going to talk about. Actually, the first point, probably most of you realize that tech careers in general, the easiest route into a tech career, it's not the only one, is through computer science. Probably the most important part is, why does it matter that we get more women into these careers? I'm going to talk a little bit about why fewer females take computer science courses, major in CS, go into tech careers, stay in tech careers. But really important part about this is not a hard problem to solve. It's not expensive. It doesn't require a great deal of talent. It does require hard work and persistence. And it requires lots of people to do hard work. So that's probably the hardest part. It's not something that any individual can change by themselves. Because in general, it requires changing a culture. And changing culture, as one of my friends tells me all the time, culture eats strategy for lunch every day. I don't know who actually said that, but somebody famous. But it's a really good point. And if you want to change culture, And we're all actually part of a culture that is in transformation. I mean, when I think about, I'm 63 years old. Are you older? He's older, good. 100, yeah. I think that was in binary again. If I think about what my life would have been like if I was born even just 30 years before I was born in 1951, so 30 years would be 1921. If you look at the opportunities for women to get PhDs in engineering and science, if I'd been born then, it would have been really tough. And yet, I was born at a time when I was one of the first people to be in my job. Well, I was the first female to be in my job for the last 26 years. So I feel like I got born just at the time when I could actually have access to a number of career possibilities that wouldn't have been there. And so if I think about, you know, like how culture is shifting, it's actually changing quite fast. And as I was talking with Mary earlier today, I was saying I think that in terms of changing culture with respect to women and other groups that are underrepresented in science and engineering, we're at the best time, at least in my lifetime. But we're not there yet. And so this bit, what can we do about it? Every single person in this room can make a difference. Many people in this room have been working on this, making a difference for a significant period of time already. But I'm convinced that the momentum is with us, and if we keep doing what we're doing, within another 5 years, we'll actually see some significant shifts. So let's talk about why it matters. So I'm going to give 3 reasons why I think it's important to get more women, and in fact, more underrepresented groups in general into tech careers. And the last one is going to be the most important. I'm not sure about the order of the first 2, so I'll just do them in either order. One of them is these are great career opportunities. They pay well. They have a lot of flexibility in them. If you're, like I was, interested in combining having an ambitious career with having children, these tend to be, because they pay well and because there's flexibility, it's a good way to be able to do that. Of course, it's not nearly as important as choosing the right partner with whom you want to have children. I was very lucky. Nick Pippinger, he's known as Saint Nick in my family. Initially, it was because you'd have to be a saint to live with Maria. Eventually, it was because he really is a saint. He's incredibly supportive. But you know, these really are great career opportunities. And why wouldn't we want women, African Americans, Native Americans, Latino, Latinas? Why wouldn't we want all of those groups to actually have access to these careers, just as a matter of sort of social justice and equity? So that's one reason. Second reason is, if you look at the economic future of this country and probably most other developed countries and developing countries around the world, their economic future is going to be influenced by their population that has good computer science knowledge and skills. And not just because you want those people all to go into the tech industry, it's because whether you're in finance or in entertainment or in education or healthcare, or you just think about any part of our economy, they need to hire more computer science people. And so, and you know, if you look at what's happening in the US, there's a phenomenal interest in the tech industry supporting diversity in computer science. And you know, much as I would like to believe that it's because they have seen the light and they see it so important, which is certainly part of the reason, I think a lot of it is because they simply cannot meet the current demand with the supply, and they have their constraints on how many people they can bring in on H-1B visas. And so they're realizing that if we had the same percentage of white and Asian males, the same percentage of women and students of color as of white and Asian males who are going into computer science, the supply would meet the demand. So that's the second reason, encouraging more people to, if not major in computer science, have a significant amount of computer science knowledge is incredibly important to the economic future of this country and many countries. But here's the reason that I believe in the most. We know that the more diverse the teams you have working on a problem are, the more diverse the set of perspectives and experiences they bring to their team, the better the solutions. So if you have a whole bunch of people who've had pretty much the same experience in life working on a problem, it's not going to be nearly as good as having a bunch of people who've had many different experiences. And what I can tell you is if you have a whole bunch of white males who not only are white males, but they are, you know, sort of conform to the traditional nerdy white male characteristic, they're just not going to find as good solutions as people that have white nerdy males and a wide variety of other kinds of people on their team, including women and people of color. So I want to say something about white nerdy males. I'm married to one. I adore him. We've been married for almost 35 years. As my daughter says, I myself, I'm not male, but I am white and nerdy. And our oldest child, our son, is a white nerdy male. So I'm very, and you know, like one of my best friends, Svi Galil, is one of those too. So you know, it's not, I don't in any way want to imply that people who make up the traditional group of people who would major in computer science or math or physics or engineering, that there's anything wrong with them. I happen to love those people. It's just that having more diversity would be better for everyone. So let's talk about why there are so few women who are interested in computer science. And you know, it's really very straightforward. There's research that that my team did in the mid-1990s and then you know, has been done several times since then, including in the mid-2000s. And the answers are pretty straightforward. If you ask, let's say, 13 to 18-year-old young women what they think about computer science, they think it's boring, they think they won't be good at it, and they think that the kinds of people who tend to major in computer science aren't the kind of people that they would identify with. And on top of that, what happens in most of our high schools, even today, is that guidance counselors will say, and teachers will say, you know, if they're talking to girls, they would never recommend that they go into computer science, even if they were interested in it. It's just not what they say. And, you know, so it's not surprising that we see a relatively small percentage of young women choosing to major in computer science. If you look over the last decade, well, let's say over the last 5 years, at PhD granting departments of computer science, the percentage of women receiving percentage of bachelor's degrees in computer science going to women has ranged between 11% and 15%. Okay, that's as low, that's lower than engineering in general. So in engineering, if you look at all areas of engineering, it's about 18.5%. Now, across areas of engineering, there's huge differences. So in bioengineering, chemical engineering, high percentages of women, between 40 and 50% female. Civil engineering, a little bit less than that. You want to see the lowest numbers? Computer engineering, electrical engineering, mechanical engineering, aerospace engineering. Okay. Now, computer science, however, has the unique achievement of being the only area of science and engineering where participation by women has declined over the last 35 years. In every other area, it has significantly increased. And for computer science, it's gone from about somewhere in the mid-30%, so the bachelor's degrees going to females, down to between 11 and 15%. In every other area, it's started quite low and it significantly increased, though in most areas, for instance, in engineering, has plateaued as of about the last decade or so. Okay, so we know why they don't do it. And we also know from research that this is something that starts pretty early, that if we look at children, the research that I was quoting here was for children aged 7 to 10, but if you were doing research in kindergarten or in pre-kindergarten, you would see similar things today. So we see differences in how boys and girls use computers, what they want to do on the computers, and we also, from very early ages, if we ask them, how good do you think you are at doing stuff with the computer, the boys will rank themselves higher than the girls will rate themselves.
But
and
boys always think that they're higher than
it's
they
exactly what I was going to say next. So, I mean, you do have to take into account the fact that there's lots of research, and not so, well, it might be for boys, but certainly for adults. If you have a group of men and women who have been selected to be at the same level of achievement, whether it's at very high levels or mid-levels, and if you ask them to rate how well they are doing, the men will overestimate how well they're doing, and the women will underestimate how well they're doing. So you were absolutely right about that. Okay, so the issues that we're dealing with are that in our country, we tell our young people, do what you love, do what you're good at, and you will be successful. If that's how our young people choose their careers, which is largely true, it is not surprising that very few women are going to enter college expecting to major in computer science because they don't think they're going to be good at it, and they think it's less interesting. So, I mean, why would anyone be surprised? But on top of that, there's another factor that is going to influence not just how you choose which career you're going into or which discipline you're going to study, but the likelihood that you're going to persist in it. And one of the things that, again, we know from research is that young women are much more likely, and let's say old women like myself, and everything in between, are much more likely to suffer from the imposter syndrome. So raise your hand if you know what the imposter syndrome is. Okay, just about everybody knows, but there's a few people who didn't raise their hand, so I'm going to talk about it briefly. So the imposter syndrome is most people perceive that you are successful with your career, and yet you yourself don't really feel successful. You feel to a large extent that you're a failure, and that you really feel like the fact that many people think you're a success, it just makes it worse that you feel like you're a failure. So first of all, it's really common for both males and females. It seems to be more of an issue for women, particularly women who are in areas in careers where women are underrepresented. And I first started talking about the imposter syndrome about 20 years ago. And the first time I gave a talk about it, I was astonished. And when I talked about the fact that this is something that happens almost every day, I wake up with this voice on this side of my head saying, "Oh, Maria, you're such a failure. I cannot believe you're such a failure." And then on the other side of my head, there's a voice that goes, "Maria, you can change the world." And I don't think it's actually unusual to have those two voices together. And so I just pay a lot more attention to the one that says I can change the world. First of all, I like that voice better. But it doesn't stop that other voice to be there in my head. And one of the things I discovered by starting to talk about it is how many people had the same experience and thought they were the only one. And so one of the things I've decided, so there's a couple of things about the imposter syndrome. One of the things, after having spent a lot of time talking about it, talking to other people about it, and looking at research, I've decided, well, first of all, let me ask you, how many people have this feeling from time to time or a lot? Yeah, it's really common. Okay, so I've decided the following thing. There is a reason why having the imposter syndrome is correlated with success. Because it causes you to be more successful. So let's think about that for a moment. And I call this theory the embrace your inner imposter concept. So why would that be the case? Well, the first thing is, if you have the imposter syndrome, you often perceive something you've done. You see where you did not achieve the expectations you had for that, whatever that was. So that means you had high expectations, and just having high expectations for yourself is highly correlated with success. But the second thing is, when you feel that you have not achieved, when you feel like you failed at something, you're much more likely to analyze it. To go over it in your mind over and over again. If I'd only done this thing or that thing, it would have been so much better. Well, guess what? That's a great learning experience. We learn so much more from failure. And so if you're going to go through life perceiving many of your things as not living up to your expectations, you're going to go through a lot of thinking about how you might actually be more successful, more effective in a particular thing. So I actually think that having the imposter syndrome is not a bad thing, except for one thing. When would having the imposter syndrome be a bad thing? Yes?
When you opt out of opportunities because you don't feel qualified.
There, perfect, right on. When you don't choose, when you either give up too early or you don't even take a risk to reach for something because you don't think you're qualified for it or you don't think you would succeed. So, the reason I'm spending a fair amount of time talking about the imposter syndrome is one of the things we can all do is if you have to be somebody who, like me, deals with this on a regular basis, we cannot let that stop us from persisting and for reaching out and trying things. But even more importantly, we can encourage the others around us. We can be mentors to our peers, to people who are more senior than us, people who are more junior than us, and we can encourage them when we can see that they're going to hold themselves back. Okay. So if you want to get more women into computer science and tech careers, or really into anything, all you have to do is increase their interest, you have to increase their confidence, and you have to provide encouragement. And, I happen to be giving this talk about women, but I actually think that in general, whether we're talking about women or African Americans, Native Americans, Latino, Latinas, any of the groups, lesbians and gays, artists, football players, any of the groups that we tend to see underrepresented in science and tech careers, if you increase interest for them, if you increase their confidence that they'll be successful, and if you provide support and encouragement, in fact, it will work, at least in my experience, for pretty much everyone. Now, I want to say there are some things that we're not, in making these claims, there are some things I'm not accounting for that I have to put in a caveat just for a moment. So, it's all very well to say, I'll take a well-prepared student of any kind who's had good high school preparation, who's had support throughout middle school and elementary school, and say, we'll do all these things and it will work. What it doesn't work for is if you have students that, and this is the majority of students who come from low-income families in this country, who've gone through crummy elementary school, crummy middle school, and crummy high school in terms of preparation in math and science. There's a lot more that needs to be done to cope with that problem than just working at the college level. But for people who are arriving at college, which certainly is, in general, young women graduate from high school with better grades than young men. So our inability to graduate many of them in computer science and engineering is not because they're not prepared for it or capable. Okay, so now I'm going to switch and I'm going to talk about Harvey Mudd. So I am wearing, I'm one of these lucky people. There's very few presidents of colleges and universities who can wear a t-shirt most days of their life. Harvey Mudd is one of the few places that you could be president of and wear a t-shirt most days of your life. So there's a couple of reasons. One is a lot of people wear t-shirts at Mudd. And I'm a computer scientist, and computer scientists wear t-shirts. Where is your t-shirt? Most days of their life. He got dressed up for me. I actually had this dream where I got dressed up for this talk, and I was wearing...
Well, you don't dress a mini anymore.
Yeah, you know, I looked at that skirt, and I couldn't even recognize it. So I didn't even know I had skirts. In fact, I wore a skirt once at UBC, and the provost didn't recognize me because I was in a skirt. I mean, there have been people who've walked up to me and literally have said, I've never seen you in a skirt before in my life. But Nick has seen me in a skirt at least 3 times. So that's one of the reasons I can wear a t-shirt. But the other reason is we're in a really big campaign to raise awareness of Harvey Mudd College. And so whenever I, give a talk at another institution or ride on an airplane, I try to always wear a Harvey Mudd t-shirt so that I figure I can raise the awareness of at least a few more people. And her husband Dan were picking me up at the airport yesterday, and they had no difficulty recognizing me because I had a Harvey Mudd t-shirt on. If you can probably read this. It says the most amazing college you've never heard of, and never has been crossed out, and it's now ever, because we are finally getting to be a little bit better known. We felt that saying never was not quite accurate. So this is the latest version. Okay, so I'm going to talk about one of the most interesting transformations in terms of gender in computer science. And I will say I've had an enormous amount of credit for this. It happened in my first 4 years at Harvey Mudd, and we went from being 10% female in our CS major to 40% female in our CS major. And I'm really grateful for all the credit, but I deserve like this much amount of the credit, and this amount of the credit goes actually to everybody else who was involved, which was primarily the computer science faculty at Harvey Mudd. So, if anyone talks to you about this, it was really the CS faculty. And one of the ways I can prove that is they started working on it the year before I arrived as president, and that was before I'd even been contacted about being a candidate for the president of Harvey Mudd. So I'm going to start by just giving you some background about women at Harvey Mudd more generally. So I arrived in summer of 2006. Before that, about 1/3 of our students were female. About 1/3 of our faculty were female. And about 10% of our computer science majors were female. And today, about 47 or 48% of our students are female. 48% of our first-year students this year are female. That's been true roughly for the last several years. And about 40% of our faculty are female. Now, what percentage of the faculty at Georgia Tech are female?
21, 23%.
Okay, so that's actually pretty good. So about 21, 22% of the faculty at Georgia Tech are...
It's mostly engineering, so it's very good.
No, that was exactly going to be my point, is that Georgia Tech, just like Harvey Mudd, is basically a science and engineering institution. So MIT, I think, is a little bit more than 15% female. Caltech hovers around the double digits, so they're 9% or 10% or 11%, maybe 8%, depending on the particular year. So, to be 40% female is really pretty incredible for a school that is a science and engineering school. And today, 40% of our CS majors are female. That has been true since about 2010. Okay, so how did this happen? Well, I'm going to start with a little bit more background than what it says on the slide. So what really happened was there was a young woman named Christine Alvarado who arrived as an assistant professor in computer science in 2005. And Christine is no longer a faculty member at MUD. She moved to UCSD 4 years ago, maybe, something like that. What's that? So we can blame Alex for all this? Yes, we do, actually. So when, did he go to, he did his PhD at MIT, though, right? He's okay. This is one of these things where they arrived in California. They thought it's about 120 miles between UCSD and Harvey Mudd. That's a lot. No matter where you put your house in between, it's going to be long commutes. They had their first child. They were still separated. Christine got pregnant a second time, and she ended up going to UCSD.
Los Angeles is even worse than Atlanta.
Yes. Oh, way worse. There's no, as far as traffic goes, I mean, it's just incredibly bad. But anyway, Christine arrived, and Christine had an interesting experience. As an undergrad at Dartmouth, she had a great experience being a female CS major. And then she went to do her PhD at MIT. And she ran into some graduate students and even some faculty who, for the first time in her experience, said, "You don't really belong here. You're female. You only got in because you're a girl." Now, she really didn't like that. And when she got to Harvey Mudd and found that only 10% of our CS majors were female, she sort of went, "There's got to be something we could do about this." And so she and a number of the faculty started reading all of the research that had been done on how to increase the number of women majoring in computer science. And the first two places that really started working on this in the 1990s were Carnegie Mellon. Many of you probably know the book Unlocking the Clubhouse, and the University of British Columbia, which you probably don't know as much about since it's in Canada. And as far as I can tell, Canada is invisible to the United States for the most part. I lived in Edmonton from the age of 12 to when I got my PhD, so 25. And I remember literally meeting the first few times I was in the US, people would say, "Do you live in an igloo?" I'm sort of like, well, you know, Canada. The work most of the work that had been done, and I want to say Georgia Tech was also one of the relatively early, particularly some of the work done by Mark Gusdale, who's apparently someplace else with Jim Foley right now. Yeah, he sent me an email. I think there might be someplace with snow, like Chicago, maybe. At any rate, Mark was also one of the people who did some of the early work looking at the impact of the intro course in terms of interest in computer science. So anyway, they read all of the literature on this, and then they started working on it. So the basic things they did were to change the introductory computer science course to increase interest and competence. Now, one of the advantages Harvey Mudd has is that every one of our students has to take a CS course in their first semester at Mudd. They also have to take math, physics, chemistry, biology, engineering. What was that? Humanities, social sciences, and the arts within the first 3 semesters, and they take a ton of them. But you know, the fact that you have a captive audience, every student, is a great advantage. They also, and this was Christine's idea, was they started offering our first-year female students. So at Mudd, you don't pick your major, or you don't have to pick your major until your end of your sophomore year. And independent of what they thought they might major in, we offered all of our incoming first-year students the opportunity to go to the Grace Hopper Celebration of Women in Computing. So raise your hand if you've been to Hopper. Okay, relatively small number of people. Founded in 1994 by Anita Borg and Telly Whitney, the idea was, let's provide a conference that really celebrates that we have women being successful in computer science careers. And it used to be every 3 years, then every 2 years, and it's been annual since 2006. Had 8,000 attendees last year, up from 4,000 the year before, up from about 3,000 the year before that. The vast majority of the attendees are female, but for males, it's an amazing experience because you get to go and have the experience that every female computer scientist has day in, day out in their life about being a minority, and it is really a great experience. But it's also, it's a celebration, it's fun, it's enthusiastic. It shows you women who are dressed like me, and then it shows you women who are dressed with heels like this, and makeup, and fancy hair, and everything else in between. It's awesome. And our goal by taking those young women, well, no matter what they were going to major in, was to show them that this as an area of science and engineering, like other areas of science and engineering, where women can be successful and have an enthusiastic experience. And then finally, for 4 years, we got a grant to offer 8 to 12 female students an opportunity to do summer research in the summer after their first year, because we know from research that getting engaged in research as an undergraduate increases retention and increases your sense of community and interest in the discipline. And so our idea was, even if it's a relatively small number of young women we can get engaged in research, they'll talk. And the fact that they're working on, say, epidemiology or on robotics or whatever, the fact that they can see that what they're working on actually makes a difference is going to have impact. So I'm going to spend a little bit of time talking about what the changes were in our intro course, because in terms of what can be replicated elsewhere, I think the single thing that institutions can do that will have the most impact to start with is to train your intro courses. Now, it's definitely not enough, because if you change your intro course, but then the second course in your sequence is still intimidating and boring, well, they learned something, but they're not going to become CS majors. And similarly, if your third course, if you make your first 2 courses interesting, accessible, supportive, exciting, and then your third course is viewed as a weed-out course, okay, this is the one where you find out if you're really a CS major. Again, that's not good. So, you're in all cases, what you're trying to do is create a culture that says, this is something that lots of different people are good at, something that lots of different people will love, something that we expect all of our students to thrive in and to have a great experience. And certainly looking at the caliber of the kinds of students that come to Georgia Tech, I mean, it's just like Harvey Mudd. Any student who is admitted to Georgia Tech ought to be able to thrive in pretty much any major here, because they're good students, they're hardworking students, et cetera. Okay, so our intro class was pretty standard class, taught a bunch of the basic concepts in computer science. It was contextualized as learning to program in Java. Okay, so I want to distinguish between what got taught in the course and how the students saw the course. Because what gets taught in the course today is the same as what got taught before. We didn't dumb it down. We didn't reduce any of the rigor. But it's framed differently, and that's incredibly important. So it used to be a learning to program in Java course, and now it is framed as a team-based creative problem solving in science. Well, we're a science and engineering school, so looking for problems in science makes sense. Using computational approaches, we had to get the computer in there somewhere, in Python. Okay, so let me go through this. So team-based means it's a social endeavor. That's really important to young women. It's important to lots of people, men as well. Creative. There are very few young people in our society who do not want to be seen as creative. Problem solving. Again, really attractive to most of our young people today because most of them want to make a difference in the world, and that involves problem solving. I mean, you could use media, like computational media, like Mark pioneered. But we happen to use science, computational approaches. Python, the choice of the language is important. The reason is it's both a practical language that gets used in industry. That's important so that you can actually get summer jobs. And it's a much more forgiving language than Java. We grouped our intro CS sections by prior experience, initially into gold and black. So gold, you can see my gold shoes. I'm wearing black. Black and gold are our colors. So is white, actually. So if you were just thinking about which color you'd rather be in, black or gold, which would you prefer? Gold. I'd want to be in gold. OK, that's the one with little or no prior experience. Black is for students with some prior experience. Green is our one that is motivated by biology. And then we have some students that just have way too much experience for an intro course, and so we put them into a special section that covers our first two courses. Now, one of the things that's really important is we're taking students and putting them in two different sections. There's a fair amount of difference about the prior experience. You know, APCS probably puts you into black. So, but we make sure that when they get to the end of one semester, they're both at the same place. And, you know, I'd never asked the question, how do you do that? And then somebody asked, from actually UBC, who wanted to implement this, and he says, how do you take those students? And they're starting with a big difference in terms of how much they know and get them to the same place at the end of one semester. What's the answer? OK, so about half of the course is not stuff that you would have taken in high school. It's basically theoretical computer science and functional programming, which you get very little of in high school, no matter what you do. OK, so for that part, they're going at roughly the same speed. The other half, the kids in black will know really very well. So you're just going to be really summarizing it and speeding through that. So you've got, let's say, 40% of the time, you've got to fill. You just fill it with random, interesting things about computer science that are not applicable until they're, say, in their junior year. And so you just pick things that won't have anything to do with the next couple of courses in the sequence, because you want to make sure that when those students start the next course in the sequence, they're at the same level, so you're not intimidating the ones who came through gold. So you give them good material. You give them interesting stuff. You just pick it to be completely irrelevant to the next two courses. It's amazing. It works like a charm. Now, also very important. OK, Svi, come on up here. So Svi is in my class. And I love this student. You know, like he's let's say I'm teaching CS5 Gold. And, you know, he loves computer science. And whenever there's a question, he raises his hand. And he's so enthusiastic. That's what I was like as a student. I want to answer. I want to answer. And then sometimes, you know, he raises his hand because he wants to tell me something he knows that nobody else in the room has a clue about. OK. OK, how do the other students feel about this? It's terrifying.
So you don't let him speak?
Yeah. So here's what we do with the Svi in my class.
Reject him.
No. I have a conversation with Svi outside of class, one-on-one. Nobody else is there. And I go, Svi, you're one of my favorite students ever. You know, I just love how passionate you are about this, and I love how much you know, and I love talking with you about it. You probably didn't realize that some of the other students don't know as much as you do, and they're a little intimidated. Could we have our conversations one-on-one in office hours? Would that be okay? He's thinking about it. He's thinking very hard.
Of course.
Exactly. Thank you. So, often when I have this, he's leaving. Hey, after those photographs you showed me, you can't be mad at me. Besides,
my keys and my iPhone in the office, and it's now locked.
It works. And, sometimes people will say, well, that works when you have classes. Well, I've got to tell you, our classes have, because this course has become so popular in the Claremont colleges, we have classes with 250 students or 299 students now. So, it might not always be the instructor. It might be, for us, it's not TAs. It's something called GRUDers, stands for grader and tutor combined. But somebody has that conversation just so that that student knows that they can have those conversations, they can have them at great length, but just not in class. And yeah, we refer to that as macho bad behavior. And not that they're bad people in any sense. Okay, so female students to Hopper. So this, Christine thought about it, was the person who initiated it. We took 12 first-year females in 2006, 36 in 2010, and about 60 this year. Now, in fact, they weren't actually 60 first-year females. It was one year when we took maybe 50 first-year females, and it completely disrupted our lab schedules because that was more than half of our first-year females. We have an incoming class of less than 200, and at roughly 50-50, it really made things problematic. So now what we say is we offer every student who comes to Harvey Mudd, every female student, the opportunity that they can visit Hopper at least once while they're a student there. And we take 25 first years each year, and we take the remainder as upper class students. And that's turned out to actually work really well for us because in terms of the opportunities at Hopper for internships and things like that, it's actually better to have many of the students be not first years. You might say, okay, that's pretty expensive. It costs us between, let's say, $700 and $1,000 per student each year. So 60 students it's a sizable chunk of change for a small place like Harvey Mudd. But I will tell you, and presidents spend a lot of time fundraising, easiest thing I've ever raised money for in my life. I mean, it's just trivial. So just to give you an example, which will be this one. Okay, so I did a crazy thing last summer. I was giving a talk to about between 200 and 300 CS department chairs, and it was on increasing diversity in computing research. And I was trying to persuade a lot of these chairs that they should do try the same kinds of things as we tried. And towards the end of my talk, I was hoping to get 10 to volunteer, that they would do it. So I said, for the first 10 that volunteer, I will try to get some money to help you send your female students to the Hopper conference. And 15 signed up before I finished the talk. And I was a little worried because I didn't actually have anyone committed to give money for this before I made this commitment. I had commitments from, Facebook, Google, Microsoft within 3 days. In fact, I only knew about 10, 11 of the department chairs because my junk mail. I didn't find them for a week. And then I had to find more money, so I got more money out of Intel. And so right now we have 15 departments across the country that have committed that they are going to work on at least 3 of the 4 following areas: revise their intro courses, build confidence in community, outreach to high school teachers and students, and promote double majors. And it's everything from huge places like Arizona State University to relatively small places like the Missouri University of Science and Technology. Many of the chairs who volunteered are early in their term as chair, and they saw this as something, a signature sort of thing they could do in their department. I believe 2 of the 15 chairs are female, so primarily male. And one of the things that we're doing while we're doing this project is We have 2 researchers, well, a researcher plus her PhD student from UCLA who are actually studying the chairs to monitor what happens over the period of this. We're in our first year. I'm super excited about this because I really believe that if we can demonstrate that 15 departments can decide they're going to work on it, and let's say 2/3 of them actually make significant progress, hopefully all of them will, then it's going to be very hard for the random average computer science department to say, oh, this is not something we can do. They are not receiving a lot of money. They're getting $30,000 a year that they can use for sending their students to Hopper or for any of the other things on this. So I'm particularly excited to see something that is being undertaken by a whole bunch of different kinds of institutions. I believe only 2 of the institutions are private, so they're mostly public institutions. So that means they're generally institutions that have less funding per student. So we'll see what happens. So what can we all do? Encourage others. I cannot tell you how important it is to encourage others. We can, each of us, aim high and embrace our inner imposter. We can talk about the lack of women. I cannot tell you how many times I have seen a list of proposed people for something, speakers for a fancy conference, possible board members, whatever. And there's hardly any women on that list. So it would be really nice if lots of people would say, why are there so few women instead of just being me? And then attending, it doesn't matter whether it's Hopper, but attending a conference that is aimed at increasing diversity is a wonderful experience. I just was at Tapia last week, which is the celebration of computing among people of color and people with disabilities. It's just an amazing experience to walk around and be in a minority as a white person and be in a computer science conference. That is a wonderful experience from my perspective. So, happy to answer questions. Yes?
So, I think we are at 23%, but a big part due to computational media.
Right.
And I am sorry that Mark is not here, but maybe Barb would ask it better, because I asked them, because we do many of the things, maybe not all. First of all, outreach to high schools, we have Tremendous by Georgia Compute. Mark and Barb has this enterprise, which we are very proud of. And actually, Mark claims the problem is not in college, the problem starts before. And that's the challenge.
Yeah, so, I mean, so the first thing I would say is that...
and we inched a couple percentage points in the last few years, but we are still
well, so the first thing I would say is that if you're at 23%, that's not something to be sorry about. That's something to celebrate, because you are at more than, you are between 1.5 times and twice the average across the country. So first of all, that's great. So I know you want to be much better than that, and I applaud you for wanting to be much better than that. But I don't think we should diminish the fact that that's a really good number. And I'll just say, at the University of British Columbia, which is where I was for close to 15 years, we went from, when we started, we were at about 15%. We managed to get up to 27%. Then it fell back to about 22%, and then now it's back up around 27%. So, I think that when you're working in a public institution, when you don't have a required course, or when you're admitting to a major, there's a lot more constraints. So, and you're a lot more...
You're admitted to a major.
You admit to a major?
So they can switch.
Yeah. They okay.
Can switch, but
so let me talk about Cal Poly SLO, which is Cal Poly San Luis Obispo, Cal State institution. They managed to get from 12% female in their incoming class to 29% over a 5-year period that included the recession and huge budget cuts. And they did it, and they have all kinds of constraints. They admit to a major. They're not allowed to influence admissions. They're not allowed to try and persuade people to switch majors. That's apparently against their culture. So what they basically did was they took the women they already had, and they made them happy. So they changed their intro course. They started Wish Club, Women in Software and Hardware. They took them to Hopper in large numbers.
So we go to Hopper.
Not in large enough numbers, though. Numbers?
40 or so.
That's not bad. That's not bad. But I mean, we're only 800 students. How many students is 21,000? Is that what I heard here? Come on, you guys can do better. However, I mean, 40 is a great number. I'm just kidding.
Majors is 300 a year, 200 to 300, close to 300.
A year?
Yeah.
Yeah, we're at 80. So if we're doing 60.
You're 80 women. You're 80 women.
No. We are 80 majors a year. You're 300 a year. That says that you should be, basically 4 times us. So we're taking 60. You're taking 240. Okay. You can do better. I'll help you fundraise. He doesn't want my help. You saw that. He doesn't want my help. Okay. But anyhow, they took 110 students to Hopper, Cal Poly SLO, this year. They're getting, you could get money from industry big time to do it.
You do?
Yeah, exactly. So you can take as many as you want. But anyhow, so Cal Poly SLO, they made them happy. And then because they recruit to their major, they simply sent all of their female students back to their high schools. And again, this works for you guys because a lot of your students are coming from Georgia. Back to their high schools, so most of their students are coming from California. Back to their high schools over winter break. And just to say, wow, this is the best program ever. It's absolutely fantastic. We love our courses. We get great summer internships. We get to go to the Hopper course. You guys are probably doing this already, but, it's, yeah. So I think 23% is awesome. And, I think what I know from my own experience at UBC is...
the same advice, encouragement.
Yeah, exactly. It works. What can I say? Support and encouragement, it works.
Yes.
Anyway, I do...
Encouraged.
Yes, he's encouraged. Good. That's what we wanted. More questions? Yes?
A great panel at Hopper this year was talking about the HR directors at tech companies talking about unconscious bias and unconscious bias training. How do you recommend addressing unconscious bias in a university, so among faculty and administrators?
Oh, what a question. So one of the things, so how many of you heard about the interview I did at Hopper with Satya Nadella? So one of the things I'm really proud of is that Satya Nadella has decided that every single person at Microsoft is going to have training on unconscious bias. He started by having the senior leadership team go through it because he said, if I can make that kind of mistake, probably few other people could make it as well, which I really loved. So, so I'm going to start by saying the following. One of the things I love about working at an academic institution is the fact that so much of what happens at the institution is done by the faculty. It's really, it's not only done by the faculty. The staff and students are also really important, but the faculty play a really major role. So one of the things I would say about, particularly in terms of doing unconscious bias training for faculty, is to really get a lot of input from faculty about how you want to do that training. And there's play, there's online training, there's a lot of different possibilities. But I think it has to be, you have to have a bunch of faculty who really, and in this particular case, I'd particularly say you have to have white males as well as females and people of color who really buy into it, because you need to have faculty leadership in really demonstrating that this is something that they believe is important. So that's the first thing I would say. And I also think that faculty are probably the most important group to work with first, because I think if faculty really buy into how easy it is to have unconscious bias, and I certainly want to say, you know, every person in the universe, I think, suffers from unconscious bias because we were all raised in a cultural environment that promotes certain stereotypes. And, you know, we can all work on our unconscious bias and reduce it, even if we might not entirely get rid of it. So the reason I think faculty are so important is because if faculty really understand and believe in it, they can introduce it in their classes in ways that will be incredibly, and for their graduate students as well, that will be incredibly influential on those students in a way that if a non-faculty member introduced it, wouldn't be as effective. I think it's also really important to have, you know, I think staff play a really important role in institutions as well, in terms of, because I certainly know, if I think about Harvey Mudd College, so we have about 90 faculty, we have about 200 staff, we have 800 students. And I know that our students interact with the staff a lot. And whether it's the dining staff or the Dean of Students staff or, you know, the staff who are the technicians in the labs, those people actually really matter as well. And one of the things that was, for me, incredibly wonderful was we have an orientation tea with the president reception for parents and their kids. And the catering staff, the person who heads up the catering for those kinds of events, her name is Bernice, and she's Latina. She came up to me after that, and she said, Maria, maybe she said president, I'm not sure. The students look really different this year. And I said, yeah, they do. And I said, so how are they different? She said, they look like us. Our incoming class this year was 38% white. It was really pretty significant. And it was more than 20% Latino, Latina. I mean, it just was a much different class. And she was right. They looked more like her. And to me, that was just a very big deal. Yes?
Since you brought it up,
yeah.
What did you think of the reaction to Satya Nadell's?
Oh, thank you for asking. So probably not everybody knows what this is about. So as I'm on the board of Microsoft, and one of the things I did about a week after Satya became CEO was to ask him to come to the Hopper conference. And I really wanted him to come because we'd never managed to get a CEO of a major tech company to Hopper. And there's something they have called the Technical Executive Forum, and I wanted him to be the first CEO of a major company who would come to that. And I told him, and if you say yes, then I'll go after a bunch of other CEOs and try to persuade them to come, all of which happened. And within a week, he said yes. And then after he said yes, then Telly, who's the CEO of ABI, said, could you persuade him to do a plenary? And so I emailed her and I said, well, seeing you're going to be here, would you like to do a plenary? And you could either do an interview or you could do a fireside chat. And he chose fireside chat. So then we decided that we would raise questions, and we got questions, and he picked the questions he wanted to answer. And then we had the interview. And the one thing I hadn't thought about was, so as you probably already guessed, I'm pretty informal. And I didn't realize that Satya had not seen me in that role before. Because at Microsoft board meetings, it's intimidating. I'm pretty quiet. I mean, the first few times I was ridiculous. I got squashed. So, you know, I'm pretty serious there. And so we're backstage, and I'm going, Satya, we're going to run on together. And he's going, really? And then for those of you who were there, when I was talking about how I got him to come, I actually knelt down like this and said, I pretended I was begging him to come, and he was so embarrassed. That's culturally so inappropriate. I just wasn't thinking. And so anyhow, as we went through the interview, I think I put him off his stride. And so when I asked him the question, what advice would you give to women who feel uncomfortable asking for a salary increase? He didn't answer from his scripted answer. He answered from his cultural background. So he grew up in South India, and he said, it's good karma to do great work without asking for a reward. And I think it's really great for people. It's one of, he'd been using references to superpowers, and he said, I think it's one of the superpowers that women can have is that they can do great work and not want to ask to be rewarded for it, which was interpreted as he's telling women they shouldn't ask for raises, whereas he was actually saying something different, that the world would be better if nobody asked for raises and expected the system to work. And I have some sympathy with that. But as being somebody who personally has trouble asking for raises and who knows a lot of women in the audience have trouble, I felt that wasn't the right answer, so I disagreed with him and gave my answer. And it got tweeted out that he had told women that they shouldn't ask for raises. They should just let the system, and it went worldwide instantly. Okay, so my first reaction is incredible guilt. I got him to that conference, I got him to do a plenary, and I caused him to have people saying horrible things about him that he didn't deserve. My later reaction was, wow, he handled this magnificently. And he has gone back to Microsoft with a commitment to diversity. It's not that he wasn't committed before, but he now recognizes what a gap there is between commitment and actually understanding how the issues affect people. So really happy for Microsoft that it happened. And then third, it raised the awareness of gender equity in terms of pay in the tech industry in a way that simply hadn't been raised for probably, a decade, if not longer. And so, having that opportunity. So I still feel this amount of guilt and this amount of joy. Yes?
Just one more.
I grew up with my mother was an artist and a father was an engineer, a very wonderful support system in terms of science and technology and exploration and all these sort of things. And we talk about how we can address the interest in technology before high school, right? And I'm looking at elementary education for my kids, and there's such a cultural pushback on technology, on screen time and use and content and everything. What are your views on sort of managing the technology image at a young age and continuing to introduce technology at the elementary level?
That's an excellent question. So the first thing I'll say is, so I think there are some, I have seen recently some really nice software that's aimed at teaching computer science concepts without words even, so roughly ages 5 through 8. And I'm also, I know of a fair amount of really nice work that's done at the middle school level. So the one that I'm talking about for ages 5 through 8 is called the FOOS, F-O-O-S, and it's by a company, it's a startup named CodeSpark, and I just think it's beautifully done and really completely culturally, it's not gendered, it's very inclusive and those kinds of things, so I was really happy with it. I also, really limited the amount of time my kids spent watching television when they were young. I tried to convince them that the only channel our television had was, PBS. Unfortunately, my father visited once and exposed them to cartoons. It's like, but, and this is my father when we didn't even have a television when I was growing up. But, I'm a very big believer that, first of all, too much of anything is a bad idea. It's probably a bad idea to read all day, every day. That's certainly what I did as a kid. And just in the same way, it's bad to play video games all the time. It's bad to watch TV all the time. So, but I think the kinds of memes that are out there about you'll fry your brain if you spend too much time watching screens, I think it's highly unlikely. So you know, no matter, I mean, it's just sort of like vaccines. I'm probably going to offend somebody by saying that if you're not getting your kids vaccinated, you're really not doing your children a favor, let alone society a favor. You know, I think that there's all of these sort of beliefs that have very little scientific basis that become, you know, sort of cultural beliefs. And often there's not that much you can do about what happens in school, but they're only in school a few hours a day, and you can do a ton about what happens outside of school. And so, you know, I have two very still have two very mathematically gifted kids whose teachers were sure they're really bad at math, and my husband and I are both mathematicians. And well, did our thinking they were good at math have any influence on either of them? Nope. Fortunately, they eventually both came to the conclusion they were good at math. So, you know, I mean, I guess what I fundamentally believe, if like your parents, you are supportive of creativity and the use of technology in appropriate ways and all those kinds of things, they'll turn out great.
Let's give Maria a great round of applause.
Maria,
Wow.
we are honored to have you as 2015 WIS Distinguished Lecturer. Thank you for being with us.
Thank you, Mary. Thank you so much. And thank you, all of you. Thank you.
And we have a fine buffet, an opportunity to continue to talk together with each other and with Maria out in the lobby. Please join us.